Good morning, all of you. How about you? I think all of you will be fine. Dear students, today in this video we will study about universal law of gravitation. First of all, let me explain what is gravitation. In this universe, every object having masses attract each other by a force that is known as gravitational force. Let me assume a body of mass m1 and another body of mass m2. Both of the masses are separated by a distance r. It means the distance between these two bodies is r. Now there will be a force between two bodies m1 and m2. That force will be F, and that is always attractive in nature. Now we will move towards the universal law of gravitation. Universal law of gravitation states that force acting between two bodies is directly proportional to product of the masses and inversely proportional to square of the distance between them. Is it clear? Let me repeat again. Universal law of gravitation states that force acting between two masses is directly proportional to product of masses and inversely proportional to square of the distance between them. It's okay? Now we will write F is directly proportional to m1 into m2. This will become equation 1, and now we will write F is directly proportional to 1 by r square. It means F is inversely proportional to square of the distance between them. We will assume it as equation 2. On combining equation 1 and equation 2, dear students, we will get F is directly proportional to m1 m2 by r square. Now we need to remove this proportionality sign, and to remove this proportionality sign we will use a constant that is known as universal constant. We will write F equal to universal constant, that is represented by capital G, m1 m2 divided by r square. This is the final equation of universal law of gravitation. Now capital G, you may call capital G as a universal constant. Now you will ask, why its name is universal constant? It means the value of capital G, universal constant, let me write value of capital G 6.67 into 10 to the power minus 11 Newton meter square per kg square. The value of this capital G universal constant will not change anyway. The value of capital G do not depend upon medium present between two masses, size of the mass, and the place where this force is calculated. Is it clear? Why capital G is considered as universal constant? Reason is that capital G do not depend upon medium between two masses, size of the two masses, and the place where this force is calculated. That's why this capital G is considered as universal constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. It's okay? Now this equation is very important for gravitation point of view, because we use this equation to find a relation between force and mass and force and distance between the bodies. Now next, what happens when distance between two bodies become double? What happens when distance between two bodies become double? As universal law of gravitation states that force between two bodies is inversely proportional to square of the distance between them, you will write F1 by F2 is equal to R2 by R1 whole square. Now you will put the value in this equation, you will get the change in force. Let me explain. R will become 2R. When distance between two bodies become 2R, it means double. Then what will be change in force acting between two bodies? You will write F means F1, F2 it means we will have to find now R2 means to say that later value of distance 2R divided by R1, it means initial distance R, you will have to put square sign. This will become F divided by F2 equal to 4 R square divided by R square. Now you are able to write F2 equal to F by 4. This states that when distance between two bodies is double, then force will become 1 by 4 times. It's okay. Thank you for watching.